Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the missing side lengths or find the missing parts of a triangle when given three sides, 6, 9, and 4, and by using the law of cosine. So obviously you can see when we're only given side lengths, we're obviously given a triangle that is in the form of side, side, side. However, I always like to just visualize what the triangle is. So again, just like in all the other problems that I'm going to be doing here, actually I always like B up here. And all the other problems that I'm going to do, I'm just going to write in the values. Again, I like to see everything. So therefore, it just kind of helps me visualize as well as what I'm doing with the problem. So since I'm only given the side lengths, I'm not given any lengths of the triangle. Any angles within the triangle. So I obviously know that I need to solve for my angle using the law of cosines. And there's three different law of cosines, not really, but the A, B, and C's are all swapped around. So if you're going to be solving for an angle, it doesn't really matter which one you have. You only have the side lengths. The best thing to do, though, is you always want to pick the angle that you know is going to be the largest. So if we look at this, triangle here, there's only going to be one side that's going to produce the longest, or there's only one angle that's going to produce the longest side. And you can see here, just think of an angle. An acute angle is going to project on a short side, whereas an obtuse angle is going to project on a longer side. So by looking at all of these side lengths, you can see that one angle we can tell is going to be the largest angle. And that's the angle that's across from the longest side, which is B. So in my formula, I have A here. Now that could be an issue. If you're provided the law of cosines, just write out the law of cosines where B is your angle. Or what you could also do is just swap the angles and the side lengths and just make that A, and then you'd be good to go as well. But I'm just going to show you how to rewrite the law of cosines, just swapping out your variables. So if I want to figure out B, basically what I'm going to do is just swap the B and the A in my formula. So I'm just going to rewrite this as B squared equals A squared plus C squared minus 2 times AC times the cosine of B. So all I did was I wrote the law of cosines in terms of my angle B. And you could do that exact same thing for angle C. So it doesn't really matter which angle or what information you're given or what your triangle looks like. But the main important thing, I think, especially when you're given side, 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 is create a triangle so you can see which angle is going to be your largest angle. Because again, what we want to do is avoid having our ambiguous case. We want to find that obtuse angle first. OK. So now we have all our information. Let's just plug it in. So I have B is 9. So I'm going to do 9 squared equals A squared plus C squared minus 2 times A, which is 6, times C, which is 4, times the cosine of B. Now, I think one of the biggest mistakes that I mentioned in the other law of cosines problem is students trying to work through this way too quickly. My advice, just work through this step by step, problem by problem. Follow the order of operations. So 9 squared is going to be 81 plus 36 plus 16 minus 6 times 4. 6 times 4 is 24 times 2 is 48 times the cosine of B. 36 plus 16 is going to be 52 minus 48 times the cosine of B. Now, all you simply need to do is subtract the 52 on both sides. And therefore, you would have 29 is equal to a negative 48 times the cosine of B. Now, to solve for cosine of B, I'm going to divide by negative 48 on both sides. And therefore, I am going to want to get the decimal equivalent for this one. Wrong calculator. So I was able to get by for a while without a calculator, but now I have to do, 29 divided by negative 48, and that's going to give me a negative, this is long decimal, it's not very fun, negative 0.6041666, repeating cosine of B. Now, I don't really care to rewrite all of that out there because I'm going to keep that angle in there. Because if I have cosine of B is approximate this, I want to figure out what angle B is, right? I don't know any of my angles. So I'm going to use inverse cosine of second answer. So I'm going to keep that answer in my calculator. And I'm going to figure this out as B is going to be approximate 127.17. Okay? So I had to round that up to the hundredth. So I'm going to have 127.17 degrees. All right, so now I have a ratio, right? So now I can just use the law of sines, or the law of sines now, to figure out one of my other angles. Now, which angle should you figure out? It doesn't really matter which one you want to figure out. In this case, actually, you know what? I'm going to round this to 127. Because a lot of times when you're figuring, unless the problem asks you to round to a certain number, a lot of times rounding with the hundreds and so forth can be a little difficult. But I'm just going to leave this as 127, round it to the nearest whole number, unless your answer asks for something different. But the reason I'm going to do that is because I just want to show you how they're all going to work out, and not dealing with decimals will make it a little bit easier. So anyways, I need to figure out for A or C. Well, it doesn't matter which one. I'll pick A. So therefore, I know I have A over sine of A. And then I got to use the proportion of B over sine of B. Well, I do know what A is. A is 6. I do not know what the angle of A is, though. B, I know is 9. And then angle B, I just rounded and figured out is 127 degrees. Make sure, again, you are using these degree symbols. OK, so now to solve for sine of A, if you remember my previous videos, I basically can apply cross multiplication and solving. If you want to do the work on the side, you very much well can. But hopefully you understand that sine of A is going to be equal to, boom, boom. Wait a minute, what am I doing here? Is equal to 6 times the sine of 127 degrees divided by 9. There we go. No. Boom, boom, no. It's 9 and 6. There we go. Why am I getting this confused? You multiply by the sine of A on both sides. And then, so it's 6 and 9. God, I had it right the first time. So that multiplies out. Then you multiply the sine of 127, then you divide by 9. I don't know what's wrong with me. I'm sorry. OK, so anyways, let's figure this out. So I do 6 times the sine of 127, and then divide that by 9. And I get sine of A is approximate. Again, we have another decimal, 0.53242367, blah, 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 right? Again, I'm just going to use the inverse sign to find angle A. So I do inverse sign of second answer. And I get 32 equals 32.17. Again, I'm just going to approximate that as A is going to be approximately 32 degrees as I round down. So therefore, A is now 32. And then I can now do 180 degrees minus 127 minus 32. And that's going to leave me with 21. And again, if you wanted to check your answer by using your law of sines, you would get angle C is going to be 21. So there you go, ladies and gentlemen. That is how you use the law of cosines to find all of your missing sides when given an oblique triangle as side, side, side. Thanks.